Hello, you are most welcome, ladies and gentlemen, to today's tutorial. Yes, Tuesday night anatomy with Daniel Okwan. Today, we want to look at an important aspect of the cardiovascular system, being the heart. Of course, because this is human anatomy, we will be interested in looking at the human heart. So, without much ado, yes, let's set the ball rolling and look at the heart. So there we are. Yes, the heart looks more or less like a fist. Now when we say a fist, that's a clenched hand. Now it is located in the middle mediastinum of the inferior mediastinum. Okay, I've done the mediastinum, so we can visit that video to get more insight. Now this heart, in males, will weigh approximately 300 grams, and in females it will weigh roughly 250 grams. That's in adults. Now, get to know that yes, this heart is actually myogenic, which means that yes, it beats rhythmically, yes, on its own without even nervous stimulation. Surprisingly, it beats rhythmically throughout one's life without getting fatigued. Okay, it beats continuously. We say it beats roughly 72 to 75 times per minute, on average. You may get some variations with these figures. But usually we say that if it beats below the lower border, then we say there is what we call bradycardia. And then when it beats too fast than the upper limit, then we say there is tachycardia. Okay, now in the living, this heart, we say it is brownish red in color. Okay, it is brownish red in color. Now one thing that we have to also know is that yes, I've told you that it is going to be, in the mediastinum. In fact, we are in the thoracic, the cervical region, the neck region, and we are in the thoracic region. Now, in the thoracic region, we are going to have what we call the two, lungs on either side. And then in the mediastinum, the central compartment, yes, the heart together with the root of its great vessels will be there. Okay, now it tells us that yes, if you talk about this middle mediastinum, then on either side laterally it will be related to, of course, the mediastinal pleura. Okay, so we talk about pleura, then it has to do with the lungs, the serous membrane of the lungs, that's the pleura. Then of course at the lower aspect it will be related to the superior portion of the diaphragm. Now it is this side that I'm interested in telling you something, that this heart, yes, you can see that it's lying on an area where usually that's the central tendon of the diaphragm. Okay, and there is a membrane which anchors it to this diaphragm, and that membrane forms part of the general membrane that covers the entire heart, and that's what we call pericardium, because the word peri has to do with around, and cardium has to do with the heart. So pericardium, that portion over here, that fibrous portion over here, is what we call fibrous pericardium. Fibrous pericardium. Now it's very important that it limits the spread of infections, okay, into the heart area. Okay, then of course we know that the superior limit of this mediastinum will be related to, of course, the transverse thoracic plane, which is also related to the angle of Louis. Okay, now one thing that you have to also know here, I'll go to the pericardium again. I'll get to that one again. Now you get to know that we have these structures which are the roots of these great vessels, okay, either leaving or entering. So for instance, you look at this one, there's the arch of aorta. The arch of aorta is going to have three main branches. There's the ascending aorta, there's the arch which arches around the T4 vertebral level. Yes, also part of the structures that you meet at the transverse thoracic plane. Then the structures already. You are going to have, of course, the brachiocephalic trunk. Yes, you have the left common carotid and left subclavian arteries. Okay, will be there. Then of course we also know that yes, the vena cava. Okay, we are going to have what we call superior vena cava, and of course there will also be an inferior vena cava. I will show you all these ones. But you know that the superior vena cava, yes, will be formed from, of course, the left and of course the right brachiocephalic veins. Left and right brachiocephalic veins. So get to understand these things. So what I'm interested in telling you is that yes, this is the mediastinal area. Yes, still moving on with the heart. Yes, I've told you that, these are the great vessels. Okay, you can see the arch of aorta with its three main branches. Okay, and then you can also see, the pulmonary trunk. And pulmonary trunk, that the pulmonary trunk, although yes, is one of the arteries, it is carrying deoxygenated blood, and that is why we've labeled it in blue color. Okay, you can see the arch of aorta is actually red. This one is blue because it's going to carry deoxygenated blood. Post-fetal life, the only blood vessel which is going to carry, the only artery which is going to carry deoxygenated blood is going to be what we call this pulmonary trunk, which of course bifurcate to give us the left and right pulmonary veins. But you realize that yes, you can see that this pulmonary trunk, actually the right aspect of the pulmonary vein actually runs below what we call the arch of aorta, the arch of aorta. Okay, and you can also see the superior vena cava actually entering it, inferior vena cava also entering it. Now they will actually open into the right atrium of the heart. I'll be coming to it pretty soon. The right atrium of the heart, and then in the left atrium of the heart, opening into the left atrium of the heart will be the left and right pulmonary veins. There are actually four, so it means that we are going to have left and right superior, and of course left and right inferior pulmonary veins. Okay, opening into what we call the the left aorta. Now you can see there are some appendages which appear like ears, and therefore we call these ones auricles. Okay, now auricles are actually not part of the heart chambers, okay, but they are just appendages, okay, of the chambers of the heart. They are not really chambers of the heart. But of course in fetal life they were playing that role, but post-fetal life, auricles, okay, there's the right auricle, is actually larger than that of the left auricle. They don't play such role. Now other things that I want to show you is that yes, you can see these areas, you can see these blood vessels running through this kind of sulcus, okay, which we call it interventricular sulcus. Okay, so superficially or externally you can see this sulcus over here, interventricular sulcus, and this sulcus, yes, you can see some blood vessels actually going through. Now the heart is going to pump. That's where central circulation of blood is going to take place. Yes, supplying blood to all part of the body. Yes, receiving deoxygenated blood from other body parts. Then itself will have to be supplied. So it will be supplied by arteries. We call them coronary arteries. These coronary arteries will go through something we call coronary sulcus. I'll show you these ones, and these are some branches of the coronary arteries. Now I'll go through the coronary circulation with you, even as well as of course fetal circulation, so that we can actually understand these things. But they will not be drained by coronary veins. Their drainage will be coming from what we call cardiac veins. Okay, cardiac veins are going to eventually drain, okay, and they will all open into what we call the coronary orifice or ostium, which is located in the right atrium of the heart. We will actually go through these ones with you. So now, having seen this, then the next thing too that we have to learn about these ones is for us to actually understand, okay, the borders of the heart, the borders of the heart. So you can see that we are going to have what we call the upper border. Okay, when we talk about the upper border, then we are looking at actually the atria. Now normally we say that the heart is going to have four main chambers, which are, of course, we are going to have the superior chambers being the atria, and then the inferior chambers being the ventricles. But actually in the living, what happens is that yes, the atria are not only superior, but they are actually posterior superior. Okay, they are posteriorly placed. Okay, and that side is quite broader compared to the ventricular area. So we say that the base or the upper border of the heart, yes, is actually formed by the atria, the right and left, of course, atria. Okay, that's an important bit of information that we have to know. Then when we look at the right border, okay, the right border, of course, will be formed mainly by, of course, the right atrium. The right atrium will form, of course, the right border. Now this right border is roughly vertical, unlike, of course, the upper border, okay, which is slightly, we say slightly is oblique, but this one is more or less vertical. This one is more or less oblique. Then, of course, we also look at, of course, the lower border. Okay, so with the lower border or the inferior border, yes, it's formed mainly by, of course, the left ventricle. In fact, partially, left ventricle is going to play a role in that. The lower border or the inferior border, yes, is formed by actually the right ventricle, mainly by the right ventricle, with some small contribution also coming from what we call the left ventricle. Now, this is where I also tell you that, yes, the left ventricle, yes, is forming the apex of the heart. So, although the left ventricle, yes, is contributing to formation of actually the inferior, yes, border or the lower border of the heart, mainly the left ventricle is actually, yes, forming what we call the apex of the heart. So we can actually say that bulk of what we call the inferior aspect of the heart will be formed by what we call the right ventricle. Then, of course, the left border, yes, will be formed, yes, mainly by the left ventricle, as well as, of course, the left atrium together with its auricle. So these are some bits, yes, of information that we have to know regarding the borders of the heart. So this is what I was talking about. Yes, this is actually the upper border. Yes, which of course I've told you that is not only from the superior part, but actually is positioned posterior superiorly. Yes, you can see the right atrium over there. Yes, with its auricle. Okay, the auricle being the appendage over there, and then we also have that of the left atrium with these are the pulmonary veins. Okay, these are the pulmonary veins. Now you get to know that, yes, this one is more to the right, so these ones will be the right pulmonary veins, and then the left pulmonary veins will also be here. But I told you that we are going to have superior one and an inferior one for both left and right veins. So these are how we are going to see it. Okay, now you realize that, yes, there will be some kind of sulcus that I was actually showing you. Now this is the atrial region and this is the ventricular region. Okay, separating the atrium or the atria from what we call the ventricles are going to be these kind of sulcus that we have sulci over here, and these ones are known as coronary sulcus. Okay, plural is coronary sulci. Then separating these ventricles, so this one is going to be a right ventricle, then a left ventricle. Separating them will be what we call interventricular sulcus. So now I've told you that the heart will actually lie in a membrane, and that membrane that the heart will lie in is known as pericardium. In fact, it's not going to lie in it, it's actually going to invest in it, and therefore eventually surrounds it. As if there's the heart and there's a balloon, and you've actually pushed your hand through one side of the balloon, such that, yes, you've invested through the balloon, and the balloon actually covers almost entirely this area. So it means that this hand is not actually inside the balloon, okay, but has actually invested it. Okay, so that is what we call the pericardium. I've told you that the pericardium is going to have two parts. It's going to have a fibrous pericardium, which is made of fibrous tissue, dense connective tissue, okay, rich in a lot of collagen to anchor the heart to the diaphragm, superior aspect of the diaphragm. In fact, limiting the spread of infection. Then, yes, we can also see that, yes, there's another part, okay, which moves this way, and that part is known as the serous pericardium. So this is actually the pericardium proper, serous pericardium. Now this serous pericardium, let me use this one to explain. If this is the heart, okay, and this portion, okay, this portion of the balloon that is actually intimately associated with the heart, okay, this portion is known as the visceral layer of the serous pericardium. Okay, we are calling it visceral layer because we say that an organ is viscera, okay, or it's a viscera, and therefore because this part is related to the organ, closely related to the organ, we say this part is known as visceral pericardium. Now that portion which is further away from this organ, okay, and lies a bit outside, forming like a wall, we call that one the parietal layer of serous pericardium. Now you get to know that, yes, this space, there's a space between the visceral layer and of course the parietal layer of the serous pericardium. This space over here, contains some kind of fluid. Okay, it's a potential space, and this space is known as pericardial cavity. So get to know that pericardial cavity is not going to contain the heart. It is going to be a potential space which will contain some fluid which we call pericardial fluid. This pericardial fluid is roughly 50 mils. So then, what is this function of this serous membrane, serous pericardium? It's going to secrete this pericardial fluid that we are talking about, so that essentially we can actually minimize friction, as far as the heart movement is concerned. Yes, it's also going to be important in actually shock absorption. Okay, will also be very important regarding the functions that this pericardial fluid will perform. So these are some important bits of information that we have to actually understand regarding the pericardium. Now, having talked about pericardium, then what happens is that, yes, coming from actually C3, C4, and C5, ventral rami, we are going to have this kind of nerve, two of these nerves, and these nerves actually supply what we call the diaphragm, okay, and therefore we call it the phrenic nerve, okay, phrenic nerves. So this is actually, yes, the right phrenic nerve, and then we also have the left phrenic nerve, okay, left phrenic nerve. Okay, running this way. Now you can see that, yes, not only is the phrenic nerve actually supplying what we call the diaphragm, but it also be important, yes, in actually supplying. In fact, the phrenic nerve is actually a mixed nerve. Yes, it's having motor function so that the diaphragm can actually contract and relax in its response. But in addition, yes, it also gives some supply to the mediastinal area of the pleura. Okay, mediastinal pleura, and then because it is running on either side of the pericardium of the heart, then we say that, yes, it's also going to give off some sensory supply to the pericardium of the heart. So this is an important relation which we have to actually know, an important relation that we have to know. So if the phrenic nerves are severed, it will not only affect breathing mechanisms, but it also affects, of course, the role that, of course, the pericardium, as far as the sensory function is concerned. So, in fact, I'm not going to tell you something about coronal circulation, but what I'm going to tell you, I've already shown it to you, yes, and one of them is that, yes, this is the atria. We have the atria together with the great vessels, and we have also the ventricles over here. Separating the atria from the ventricles is a sulcus, okay, and that sulcus is known as, you're going to call it, the coronary sulcus. We are calling it coronary sulcus because, yes, of course, the coronary vessels, okay, left and right coronary arteries will be running through them. Again, I've also told you that separating, of course, the left ventricle from the right ventricle will be by the concavity of what we call the interventricular sulcus, and even some branches of what we call the coronary vessels will be running through it. But I'm also interested in, of course, telling you something, and these ones are what we call pericardial sinuses. We've already seen the pericardium. Now what happens is that the roots of these great vessels are also reflected, okay. The pericardium also reflects around these great vessels, so you can see one over here. It's a reflection of actually the pericardium. So what happens is that it creates some kind of impressions, okay, in the peritoneum, okay, so that they represent site for buildup of pericardial effusion. So if there is any effusion around the heart, there are some areas, in fact there are 3 areas of the heart that we are going to see these ones. And the first one, we find it actually between the ascending aorta, in front of what we call the ascending aorta. Now look at this. We are going to have the ascending aorta here. This is the arch of aorta. So in front of what we call the ascending aorta, this is the ascending aorta. This is actually, we are looking at actually the posterior view. Okay, this is actually the posterior view because I can't actually see the posterior ventricular sulcus. Okay, we're actually looking at the posterior view. So over there at the anterior aspect, there's going to be, a sinus which will be created. Okay, and this sinus, yes, will be in front of what we call the ascending aorta as well as, of course, what we call the pulmonary trunk. Now, here is the pulmonary trunk. The pulmonary trunk will eventually, bifurcate to give us, the right and left pulmonary arteries. Okay, so in front of these two, great vessels, we are going to have what we call the superior sinus. Superior sinus, very important. But another important thing, which is found exactly opposite to where we have the superior sinus, but this time around it is found, behind. Superior sinus was found in front or anterior to what we call the pulmonary trunk, as well as, of course, the ascending aorta. Now, found behind the pulmonary trunk and the ascending aorta, we are going to have what we call the transverse sinus. But not only is it found behind here, but it will actually run in front of this great vessel, which is the superior vena cava. It will run in front. So if your probe is, inserted actually behind, yes, the pulmonary trunk, as well as, of course, the edge of aorta, but actually passing in front of the superior vena cava, then you should know that the sinus we are talking about is the transverse sinus. Transverse sinus. Now, importantly, this transverse sinus, is very important clinically, especially during, cardiac surgeries. So that by passing one probe, okay, passing a probe in one end of what we call, passing a probe, okay, in between this area, between actually the, aorta or the pulmonary trunk and this transverse sinus, what happens is that, yes, you're able to actually block what we call cardiac output, so that no blood will actually be pumped out. Okay, very important, this transverse sinus, apart from representing sites where, of course, cardiac effusions may build up. Yes, it's very important during cardiac surgeries, so that I can actually block what we call output, blood output. Okay, and how do you block that blood output? Yes, a probe will be, connected or inserted between, of course, this sinus as well as the pulmonary trunk, or, the aortic, the aorta, so that you don't, ensure that you minimize blood flow, and therefore, cardiac surgeries can go on, successfully. Well, apart from this, there's also another sinus, which we call it, the oblique sinus. This time around, it will be found behind, the atria. Now, look at this. This is actually the right atrium. This is the left atrium. It will be found in between, right? In between the right and left atrium, okay? As well as, of course, between the left and right pulmonary veins. So these are, of course, the right pulmonary veins, the left pulmonary veins. Okay, there's, a sinus over here between what we call the right atrium, left atrium, so around this area, as well as, of course, between, the right and left, pulmonary veins. So these are, some dynamics that we have to know. Bear in mind that pulmonary, veins will be very important in actually bringing oxygen-rich blood, yes, from the lungs to, of course, the left atrium, because I've told you that they will be opening into what we call the left atrium. So, having seen the general organization, yes, an important thing that you have to know is that, yes, the heart is a tubular organ. Okay, this, being a tubular organ means that it's going to have tunics, or it's going to have hoods, okay, in its wall. And so, if there's the heart and I take a small section over here, then I'm going to have these kind of, coats of the heart, or tunics of the heart. So if I cut through it, there will be a central cavity. Okay, so let's say that's a lumen. If that's a lumen, then moving from the lumen externally, then the three coats of the heart will be endocardium. Endo means within. There will be a myocardium, middle for myo, M for middle, myocardium, and M for muscle. So that will be the muscular coat. And then, of course, we are going to have the pericardial coat. Now, get to know that, yes, I told you that the pericardium, this is the epicardium. Now, the pericardium, okay, the pericardium is going to have, yes, fibrous layer, and it's going to have, the, serous membrane. Now, this serous membrane, serous pericardium, is going to have two layers that I've showed you. We're going to have the parietal layer and the visceral layer. Now that visceral layer contributes to the formation of what we call the epicardium. The epicardium. So let me actually show you in a better view. Yes. So there we are. If we take a section through the heart, yes, moving away where that portion which is intimately associated with the heart, is going to have is what we call the endocardium. Now this endocardium, yes, is going to have a single layer of squamous epithelial cells, and below it will be an endocardial layer of loose connective tissue. Now remember, the simple squamous epithelial lining, yes, won't have blood vessels, and therefore will have to be nourished by the underlying, loose connective tissue, which is highly vascularized. Okay, that's an important bit. Yes, we know that in between between of course epithelial lining and what connective tissue, there will be a basement membrane, which is sandwiched between them. Now beyond that, yes, we are going to have a thick layer of muscular coat. And that is why it is very important that the heart, although it is supplying other organs with blood, it has to also get nourishment, because having cells, okay, which are myocytes, cardiomyocytes are here, and they also have to be nourished, okay, and that is what we call the myocardium. Okay, myocardium will also be here, the middle layer, the middle coat, actually having several layers of cardiac muscles. Okay, and then we also have what we call the epicardium. Epi means above, epicardium, that's the outermost, tunic of the heart. Now this epicardium, yes, is going to have, I've told you that apart from having, yes, the visceral layer of the serous pericardium, yes, it also have what we call a lot of adipose tissue constituting it. So please don't say that it is only, yes, the visceral layer of the pericardium that forms the epicardium. It actually contributes to the formation of the epicardium. Now, one thing too is that you have to know that the heart will have to be cushioned. Yes, it will be cushioned by some fat, okay, tissue around it, okay, to help in its cushioning. Now, as a clinician, yes, as a doctor or as a healthcare provider who is into disorders of the heart, then you have to be very conversant with the heartbeats, okay, the beats that we can actually listen to, okay, regarding especially where we have the valves, so that I can listen to the murmurs or any other disorder which can be actually detected through sound. So listen to the sound using, of course, the stethoscope, or using the in terms of auscultation, yes, you want to listen to it. Then there are some important valves. The heart is going to have 4 valves. Okay, 4 valves will be related to the heart, just like having 4 chambers. Yes, the heart is going to have 4 valves. Now remember that valves ensure that there is unidirectional flow of blood from one chamber, yes, to the other. So that, in other words, you want to prevent the backflow of blood. Now, you get to know that, yes, there is one valve over here, and this is the aortic valve, or that's what we call the aortic semilunar valve, or of course the left semilunar valve. Okay, although we are calling it the left, now look at where it is actually located. Okay, it's actually located, in the right, okay, second intercostal space. Now, that is why we need the angle of Louis in this regard, so that if we identify the sternal angle of Louis, okay, which is between, of course, the manubrium and then the body of the sternum, once you can identify it, the angle of Louis, then of course you know that that's second rib. Above it, that's the first intercostal space. Below it, that's second intercostal space. Now we are looking at the right second, although the aorta, okay, 8th valve, we are calling it the left, aortic or the left semilunar valve. It's actually located in what we call the right second intercostal space. So that's by listening to the sound over here, okay, the heartbeat, the lap dap that you can see, you can listen to, that will actually be coming from what we call the aortic valve. Now, just opposite, okay, to that's actually the left, okay, the left second intercostal space will be that of the pulmonic or the pulmonary valve, or the right semilunar valve, okay, or the pulmonary submural valve. This valve, okay, is the pulmonary valve. Okay, so you can listen to the pulmonary sound over here. Okay, over here. Now, over here, now, if you get to actually the right aspect of the fifth, okay, so if you count it, actually we are going to have 1, 2, 1, 2, 3, 4, and then the fifth, okay, right intercostal space, we are going to have the tricuspid valve. Bear in mind that the tricuspid valve is actually serving as the boundary between what we call the right atrium and the right ventricle. So it's not surprising that we are finding the tricuspid valve, in the right fifth intercostal space. So that sound can be listened to here. Now this time around, yes, in the same fifth intercostal space, this time around to the left, we are going to have the mitral valve. But this one, it will not just be close to what we call the sternum, but it will be around the mid-clavicular line. There's a clavicle, and so there's a mid-clavicular line. It will be around there. That is where, the mitral, sound can be auscultated. Okay, so these are, the valves that you have to know, okay, so that you know the intercostal spaces that we are going to find them. So, yes, I've told you that the heart is going to have, 4 chambers. Now we are going to actually begin with what we call the right atrium. Okay, so we're going to have the right atrium over here. Yes, with its auricle being, of course, the right auricle. Yes, the right atrium, we describe it as being a bit, quadrilateral or quadrangular, yes, shaped. Yes, that's what we are going to see. Now look at what it said. It said it's to the right of what we call the right ventricle. So this is actually the right ventricle, more or less to its right, but it's actually a posterior aspect, okay, of the right ventricle. So get to know that, yes, in the right, atrium, the right atrium will be receiving, yes, blood from what we call the superior vena cava as well as inferior vena cava, as well as, of course, the cardiac veins opening into it. Okay, now what happens is that, yes, it has to relax to receive the blood, okay, and then to contract to pump the blood to the next chamber, which is the right ventricle. Okay, so it moves this way, but before it gets here, then the valve which is separating them, with the tricuspid valve or the right atrioventricular valve, yes, will have to open for the blood to enter. I will show you these valves. Now the name is tricuspid, so it tells you that it's having 3 cups. I will show you all these ones. Okay, so that is what we are going to actually see. Okay, that's what we are going to see. Now, importantly, we've already seen that it forms, part of the, of course, the right, forms the entire right border and part of the anterior surface, okay, as well as 1/3 of the base of the heart, okay, form part of the base of the heart. Of course, the right border too, that's what, is formed by. Then get to know that it has an ear-like, structure which flaps around it, and that is what we call the right auricle. Now, let me tell you something about the right auricle, that it is going to be very important to increase, of course, the capacity of the right atrium. Okay, so whether being, of course, the right ventricle or the left ventricle, the auricles there, what they do is that they increase the capacity of the atria. Now, I'm interested in the internal view of the right ventricle. So if I take a scalpel blade, yes, cut through it, the right, atrium, then I'm going to have 2 parts. Okay, the right atrium is going to present with 2 parts, and these 2 parts, yes, are the posterior part. Okay, this area is the posterior part, and this area is the anterior part. So you can see that the anterior part is a bit roughened, the posterior part is smooth. Okay, the posterior part, which is rough, is known as sinus veranum. Now, it is called the posterior part, yes, because it is located behind this structure over here. Okay, this structure, which is, an important landmark, okay, so that we can separate this posterior part from this anterior aspect. This structure over here is known as Crista Terminalis, or the terminal crest. Okay, so this terminal crest is separating the smooth posterior part from the rough anterior part. But importantly, you can see that in this sinus veranum, which is the smooth posterior part, is receiving what we call the superior vena cava. Okay, superior vena cava. Now, superior vena cava, you can also call it, the anterior vena cava because it's more anterior, and then the, inferior vena cava is more posterior. So it is receiving the superior vena cava. Okay, so the orifice of the superior vena cava actually opens into the sinus veranum. And then, not only that, we also find, yes, the opening of what we call the, inferior vena cava. Now, get to know that superior vena cava is, draining blood, okay, to the right atrium of the heart, in favor of gravity. And therefore, yes, it doesn't need a valve to control it. But for inferior vena cava, it is having a valve. The name of the valve of the inferior vena cava is known as the Effusion valve. Okay, so it is having this kind of, eponym, Effusion valve. I also told you that, yes, the the veins, okay, eventually will be draining into what we call the right atrium. So, yes, the valve that is also guarding, yes, the coronary, yes, vessels, okay, which are draining here, will be known as the Tabasian valve. Okay, Tabasian valve. That's an important bit of information that we have to, know. But not only that, yes, we also find this over here in the wall of the right atrium of the heart. Okay, it's actually it's around where we have the interatrial septum. Okay, this one is known as fossa ovale. Okay, fossa ovale. So this, fossa ovale, yes, used to be foramen ovale, and this foramen ovale was very important in fetal life for shunting blood in between right and left, atria. More importantly, moving the blood from the right atrium to the right ventricle, so that the blood doesn't get to the right. Moving blood from the right atrium to, of course, the left atrium, so that the blood doesn't get to the right ventricle to be pumped to, of course, the pulmonary trunk to reach the lungs, because at that point the lungs are not fully, functional. And that is why I'll talk about a defect over here. I'll talk about it pretty soon. So these are, the smooth part, the smooth posterior part, which we are calling it the sinus veranum. Now, in fetal life, yes, we call it, sinus venosus. So if we hear sinus venosus, we are still talking about the posterior part, the posterior smooth part of the right atrium. But in fetal life, it is called sinus venosus. So here is the posterior aspect, the anterior aspect, which is rough, and this is actually what we call the atrium proper. I've told you that, yes, what we are going to use to differentiate this smooth part from this rough part is the terminal crest, or the Crista Terminalis. Now, we are calling it, atrium proper because, yes, embryologically, yes, this is actually the primitive atrium. This is actually, the atrium that was used in fetal life, primitive atrium. Okay, now these rough projections that we find them here are known as musculi pectinati, or the pectinate muscles. Now, what's the function of these pectinate muscles? They ensure that there's increased power of contraction, yes, in the right atrium, without the heart actually increasing, in mass or hypertrophying, actually. So these are some important bits of information that we have to know. Remember, in the right atrium of the heart, yes, we are going to have this smooth part, we are going to have this rough part. The rough part is anterior, smooth part is posterior. The rough part is actually the atrium proper. The smooth part, yes, derived from actually the sinus venosus, so that it becomes the sinus veranum, okay, that's the posterior part, and they're actually separated by what we call the Crista Terminalis. Yes, so there we are again, just to show you a real-time section. Yes, this is actually the atrium. Okay, so once you can actually feel this area, yes, this is actually the Crista Terminalis, so that it separates the anterior, rough part. Okay, by these are the pectinate muscles, and then the posterior smooth part, that's the sinus veranum. Yes, you can see the opening of the coronary sinus. Okay, which would drain into the right atrium. Okay, to be guarded by this valve, which is the Tabacian valve. Yes, the inferior vena cava also be here. Yes, its valve will be what we call the Eustachian valve. And then of course the superior vena cava also opening there. Yes, essentially it is smooth. The fossa ovale, which in fetal life was foramen. Yes, ovale. Okay. Now, also in the right atrium of the heart, in fact, in the right atrium, very important, that we see that, yes, just at the base of what we call the superior vena cava, we are going to have what we call, now I told you that heart is actually myogenic. There should be an electrical, activity which ensures that the heart beats continuously throughout one's life. And in setting the pace for this, the pacemaker of the heart is the cyanoatrial node, the SA node. Okay, just at the base of the superior vena cava. And then yes, that electrical activity will be transferred to what we call the AV node, the atrioventricular node, which is actually located in the triangle of Koch. I'll show you the triangle of Koch pretty soon. And then you can also see that yes, over here, this node actually gives us this thick area, which we call it the atrioventricular bundle, or that's a bundle of His, which will actually divide into a right portion and then of course a left portion. Okay, we're actually looking at the right side, the right ventricle area. There's a right atrium, right ventricle, and then of course gives off these kind of fibers that we call them the Purkinje fibers. Okay, these are of course all the Purkinje fibers, which will actually which are also known as the subendocardial branches. Okay, so these are it. Yes, they will be in the muscles. They're actually modified, cardiomyocytes, okay, to help in the electrical activity of the heart, so that the heart can actually beat, continuously. Now let me show you this. Yes, now you get to know that in between separating the right and left ventricle, although I'll come to it, will be the interventricular septum. There will be a septum which will separate the right chambers of the heart and the left chambers of the heart. Now get to know that in the right chambers of the heart, we are going to have the right atrium, as well as of course the right ventricle, and then in the left chambers we are going to have the left atrium, as well as of course the left ventricle. But bear in mind that only oxygenated blood is expected to be in the right chambers of the heart, and deoxygenated blood are expected to be in the left chambers of the heart. Okay, so separate, ensuring that there is this kind of complete circulation of blood, ensuring that oxygenated and deoxygenated blood do not get missed. Okay, is we are going to have this septum known as interatrial as well as interventricular septa. Okay, very important, so that it helps in that regard. So in humans, normally we expect that there is complete circulation, okay, to ensure that oxygenated and deoxygenated blood do not get missed. There's also double circulation, yes, because blood will enter, okay, deoxygenated blood from all parts of the body except the lungs, yes, will enter the right atrium of the heart, okay, and then eventually it will actually exit through after the right atrium pumps the blood to the pulmonary trunk, gets into the lungs for oxygenation, then eventually it takes another route. It enters the left atrium through what we call the pulmonary veins. I'll be showing all these things, so that yes, the blood has actually entered the heart again. Okay, and of course it will leave again via of course the aorta. So we actually see these ones. So this one tells us that yes, there's double circulation. And that is why if it is going to, of course, the lungs, then we are going to call it pulmonary circulation. Then if we go into other part of the body except the lungs, then we say there's systemic circulation. I'm not going to go through all these ones, but please get to understand these bits. Now, so here we are. Okay, now I've told you that yes, there's going to be cyanoatrial node, yes, at the base of the superior vena cava, yes, setting the pace for contraction of the heart. Yes, then that electrical activity, yes, is spread to what we call this atrioventricular node. Now I told you that this atrioventricular node will be located in this triangular space over here, which is actually located in the right atrium of the heart, actually very close to what we call the interatrial septum. And this one is known as the triangle of Koch. This triangle that the AV node, yes, is found within is known as the triangle of Koch. So for you to actually see this, AV node, okay, especially when they are doing, electrophysiology procedures, okay, physiological procedures of the heart, then what happens is that the identification of this, AV node becomes very important, okay. So this one is actually located in the superficial, paraseptal endocardium, okay. So this is the septum, so paraseptal part of the endocardium, okay, of the right atrium, okay, of the right atrium, actually quite related to the right atrium. So that, yes, you know that at the posterior aspect we are going to have this one over here, which is actually the coronary sinus. That's the ostium, or the opening of the coronary sinus, okay. And then of course you can also see that there's a tendon, which we call it the tendon of Todaru, okay, tendon of Todaru. This tendon, yes, is actually very important. We say it's a structure which actually connects, the valve of the inferior vena cava. Okay, so the valve of the inferior vena cava will be here, okay, to actually what we call the fibrous body, okay, fibrous body, central fibrous body. So this kind of tendon, which connects the valve of inferior vena cava, that's the ischiatic valve, to the central fibrous body of the heart, is known as the tendon of Todaru. Tendon of Todaru. It's also one of the boundaries. And then again, yes, we are going to have actually one of the leaflet, okay, leaflet of what we call the tricuspid valve, okay, all forming actually some boundaries, so that you can actually identify this triangle over here, which you call the triangle of Koch. Once you can identify the triangle of Koch, then it means you can actually identify what we call the atrioventricular node. So let me also say that, yes, over here you can see that there's going to be a septum, because there's a right atrium, there's going to be a left atrium over here, okay. So this is the septum, okay. So this interatrial septum, yes, will be very important, yes, so that you can separate the right atrium from the left atrium. Now you can see that also in this septum you can see the fossa ovale that we've been talking about is also here. So I've told you that this fossa ovale, yes, in fetal life was the foramen ovale, so that we can shunt blood, yes, between of course the right and left atria. Now this foramen ovale will be guarded by a limb, okay. So some kind of leg-like structures which covers it or surrounds it, and therefore we call limbus of foramen ovale, But because it also forms a ring-like structure over here, we also call it annulus ovalis, okay, very important. Now normally this foramen ovale, which in fetal life, this fossa ovale, now in fetal life was actually foramen ovale. Now immediately, fetus is actually delivered and becomes a neonate. By taking in the first breath, what happens is that we expect that it gets occluded. Now, if it doesn't get occluded, that is when there is a disorder which mostly will take place around where we have the foramen, ovale, which then includes and became patent. And this is what we call atrial septal defect. So remember that atrial septal defect, because that's the atrium, interatrial septum, and then that's the septum, okay, that's the septum. So if there's a defect over there, then we are going to call it, atrial septal defect. The commonest area which is going to take place is going to be where we have the foramen, ovale, ovale. And that is, in such situation, we call it, patent foramen ovale. Patent foramen ovale. Now, remember that in adult life, what happens is that the left atrial pressure, okay, because the left one is going to carry, yes, oxygenated blood, the pressure over here is actually greater than that of the the right atrium. Right atrium. When that happens, then blood could be shunted. You can see where the arrow is moving. So the oxygenated blood, instead of, yes, getting to the left ventricle to be pumped to actually the, ascend the aorta to be distributed throughout part of the body except the lungs, what happens is that, yes, it will get into what we call the right atrium and then may get into the right ventricle and then wasting, the oxygenated blood, actually, because it will get to the lungs again and then the lungs will have to oxygenate it because it's no longer going to be useful to the cells of the body. Okay, so that's an important bit that we have to, know. Okay, now what happens is that if the defect is quite great, okay, if the defect is quite great, just like this one is quite, very prominent, then what will happen is that it can cause, right ventricular overload. Okay, the right ventricle will be stressed enough because a lot of blood will be coming over here and may lead to what we call pulmonary hypertension. Pulmonary hypertension. Because what happens is that it won't be able to pump all the blood, yes, to what we call the, the lungs, so a lot of, pressure on the lungs as well as, of course, the right ventricle, leading to what we call pulmonary, hypertension. When that happens to, because the right ventricle will be overworking, then it may lead to what we call hypertrophy of what we call the right ventricle. Hypertrophy of the right ventricle. So that is one thing that we have to know. Very important. If surgical intervention is not timeously, yes, done, then what will happen is that it may lead to, heart failure. Actually, right, ventricular heart failure. That's an important bit that we have to know. Atrial septal defect. So yes, having seen, all that kind of things about, the right, atrium, then the next one that we want to actually know again, yes, who are actually going to be the left atrium. I want to talk about the upper chambers first, the left atrium. Now get to know that the left atrium will be receiving oxygen-rich blood, okay, from the lungs, and it will be receiving that through these 4 pulmonary veins. Actually, there are 4, okay, 2 coming from, the right side, 2 coming from actually the left side, okay. It will be from what we call the left, the pulmonary veins. Now what will happen is that for it to receive it, then it has to relax to receive it, and then it will pump it so that it gets into what we call the left ventricle, actually going through what we call the bicuspid or the mitral valves, or of course the left atrioventricular valve. So that's an important thing that we have to know, okay. But what happens is that, yes, the left atrium that we learned about, yes, is going to actually be important in forming actually the posterior border, or that's what you call the base. It helps in forming the base together with the right atrium of the heart, okay. Now it's going to also have an auricle, an ear-like appendage, which you call the left auricle, okay. Also going to help in increasing, of course, the capacity of course, the right atrium, especially during loading, okay, as blood enters it increases its capacity, okay. That's the left auricle. All right, now what happens is that the internal aspect, okay, over here of what we call the left atrium will actually be divided into 2. You have what we call an inflow part and an outflow part, okay. So here we are, this is the inflow part, because we are calling it the inflow part because that's where the pulmonary veins are opening into it. So you can see that this inflow part is actually smooth, yes, because embryonically, yes, it will be coming from the pulmonary veins themselves, so that makes this inflow part quite smooth. Now the outflow part is actually, yes, anteriorly placed, okay. The outflow part will be anteriorly placed, okay. And that outflow part, yes, will be lined by some bit of pectinate muscles, although we can't see them over here, but there will also be some pectinate muscles, okay, just like we saw in the case of the right atrium, but these ones are not very much prominent compared to that of the right atrium, but there will be some kind of pectinate muscles. And then of course, because it's coming from pectinate muscles, then it means that embryonically it is derived from what we call the primitive or the embryonic atrium. Okay, so that's very important that we get to know. So the next thing that I want to talk about is the right ventricle. Now get to know that oxygen poor blood, okay, from the right atrium will have to get into the right ventricle through this valve, and this valve is known as the right atrioventricular valve, or you can also call it the tricuspid valve. Now this tricuspid valve, yes, is going to have 3 cups as the name suggests, and these cups are what we call we are going to have what we call the anterior cups, then we're going to have also the posterior cups, and then there will be another part which is closely opposed to what we call the interventricular septum, and therefore we call it the septal cups, okay, or we can also call them leaflets only. So that's what we are going to actually see. So this one open for the blood to get into the right ventricle. Now for it to receive the blood, then the right ventricle will have to relax to receive the blood, and also contract to cause the blood to move into what we call the pulmonary trunk. So it contracts to push the blood all the way here into the pulmonary trunk. Okay, so that's one thing. Now in the right ventricle, okay, what we find is that yes, the right ventricle is actually also going to have its internal aspect, going to have 2 portions. We are going to have the inflow part, and I'm also going to have the outflow part. So let me show you the inflow part. Now the inflow part and then the outflow part, yes, will actually be separated by a crest, which is over here. Okay, this crest is known as the supraventricular crest. So outflow part and then inflow part are separated by what we call the supraventricular crest. Okay, now the inflow part, yes, will be covered by a lot of these things. Okay, now over here you can see these things, these structures over here, which are irregularly shaped structures, are known as trabeculae carni. Okay, trabeculae carni. So yes, we also find that in the left ventricle too there will be trabeculae carni, but what we find as difference will be that yes, the trabeculae carni in the right ventricle are more pronounced. Okay, they are larger and fewer compared to that of the left ventricle. So these are the trabeculae carni. So these trabeculae carni, yes, we can also have some portions of it form what we call, now look at this, although these are still trabeculae carni, there's a portion over here which we call the septo-marginal trabeculae, or the moderator band. Okay, moderator band. So moderator band is still a modified part of what we call the trabeculae carni. Yes, as the name suggests, yes, it moderates the contractions of the right ventricle. Now also part of the trabeculae carni which are also modified are these structures which we call them papillary muscles. Okay, papillary muscles, they form something like pillars over there in the right ventricle. Yes, in the left ventricle too we are going to find these structures over there. So these are what we call papillary muscles. Now because this is actually the the tricuspid valve, then the papillary muscles are also going to be 3. Yes, there's going to be the anterior portion, there's going to be also the inferior portion, then of course there will also be the posterior portion of these papillary muscles, and they will hold, they will be connected to what we call the cups of the tricuspid valve by some muscles which we call them chordae tendineae, some tendon-like structures which we call them chordae tendineae. So imagine from the trabeculae carni are modified pillars which we call them papillary muscles, yes, holding on to what we call the the cups of what we call the tricuspid valve via what we call chordae tendineae. Okay, so that is how we have it. This represents what we call the inflow part of what we call the right ventricle. Now for the outflow part, that is actually the conus part. Okay, this smooth part over here, above this supraventricular crest. Okay, this smooth area over here is the outflow part, and we also call it the infundibular portion, or we also call it what we call conus arteriosus. So you can see that it leads to where we have the pulmonary trunk. Okay, it leads to where we have the pulmonary trunk. And embryonically, it's derived from what we call bulbous cordis. When we look at the embryology of the heart, we actually be able to understand what this bulbous cordis will be doing. So you can see that this outflow part is entirely smooth. So there we are. We've seen the ventricle. We've seen the right ventricle already. Now I'm interested in telling you something about this area, this septum, which separates the right ventricle from, of course, the left ventricle. Okay, so there's going to be this ventricular septum. So in between these two ventricles will be the interventricular septum. Now bear in mind that yes, there's going to be a superior portion. Okay, there's going to be a superior portion which is actually membranous. Okay, which is actually membranous and forms part of the fibrous skeleton of the heart. And then there's going to be an inferior extent, which we call it the muscular part. Okay, muscular part. Okay, and this muscular part actually forms vast of the interventricular septum. Remember, this interventricular septum is very important in ensuring that there is complete circulation of blood, that no oxygenated or deoxygenated blood gets missed, which may actually be dangerous. So there we are. I've already told you that, of course, the left ventricle and of course the right ventricle, they will have similar architecture. Yes, I've told you. So here we have the right ventricle. Now get to know, just by simple observation, you get to know that the wall of the right ventricle is actually thin compared to the wall of the left ventricle. The wall of the left ventricle is quite thicker. Yes, the reason is that it has to pump blood quite powerfully. Yes, so that the blood get to the ascending aorta, to the aortic arch, to a various part of the aorta, to be distributed to all part of the body except the lungs. So the pressure with which it has to pump to all these parts of the body will have to be enormous. Okay, so that is why this one is having quite thicker wall compared to that of the right ventricle. Now there we are. Now you also see that yes, just like the left ventricle, sorry, just like the right ventricle. Now what happens is that the left ventricle will be receiving blood from the left atrium. What type of blood? Oxygenated blood. Oxygen-rich blood will be received from it. Now for it to receive it, it will have to relax to receive the blood, and then to contract to push the blood to the aorta to be distributed to all part of the body except the lungs. Okay, so this is an important thing that we have to know. Now what happens is that yes, we can also divide its internal aspect into an inflow part, okay, inflow part, and then of course an outflow part. So just like what we saw in the case of the right ventricle, this inflow part will actually be roughened, okay, will be roughened by what we call the trabeculae carni. Just that get to know that we don't have septomarginal band, or we don't have moderator band or septomarginal trabeculae, okay, in the left ventricle. That's what we don't have. But essentially, yes, we are going to have trabeculae carni to make the inflow part rough. Okay, again, yes, emerging from this same part are some pillars, and these pillars are known as the papillary muscles, which will be connected to the two cups of what we call the bicuspid valve, two cups of the bicuspid valve, and that is what we call the So we've seen the chordae tendineae, yes, connected to the two cups of the tricuspid valve by what we call, they'll be connected by what we call some tendons, tendon-like structures that we call them chordae tendineae. Okay, so that is what we're going to find over here. So an important thing that you have to know, okay, that's very important that you have to know. So there we are. Let me just show you the mitral valve. Yes, it looks like a mitre of let's say a bishop or a pope. So that's why we call it mitral valve, also called bicuspid valve, also called, yes, the left atrioventricular valve. Now bear in mind that, yes, sometimes if this valve is incompetent, okay, in situation we call something severe mitral valve incompetence, then what happens is that instead of the blood getting into the right atrium and enclosing, what happens is that blood can actually get back, regurgitate back into the what we call the the left atrium. If that happens, then there's going to be a problem, because what happens is less oxygenated blood will be pumped by the left ventricle to the aorta to be distributed to all parts of the body except the lungs. So please get to appreciate that. So as I told you, yes, we are going to have this kind of roughened area, and this roughened area is the inflow part of the left ventricle, okay, and it's roughened because of the trabeculae carni, which are actually numerous but finer. Then we're also going to have what we call projections, something like pillars coming from the trabeculae carni only, and these ones are the papillary muscles. These papillary muscles will be connected to the cups. Okay, we've told you that we're going to have anterior cups and the posterior cups, or these are the leaflets or the leaves of the bicuspid valve. They'll be connected by what you call the chordae tendineae, okay, over there. All right. Now, so that's the mitral valve. Okay, that's the mitral valve, and I was actually showing you that, yes, indeed, this is actually the inflow part. Now for the outflow part is a bit smooth. Okay, so somewhere here it's a bit smooth, and the outflow part is actually derived from what we call the bulbous cordis. This one we can actually appreciate it quite much, and that is what we call the aortic vestibule. Okay, get into somewhere around the aorta, aortic vestibule. All right, so now let me tell you that for the blood to move all the way, okay, from now please get to understand that the atria will be less thick-walled compared to that of the ventricles, and even with the ventricles, we know that the left ventricle is going to be quite thicker compared to the right one. Okay, that's an important fact that you have to know because of course, functional differences. Now the ventricles, so I'm interested in the right ventricle. Now the right ventricle, upon receiving blood from the right atrium, will pump that blood, okay, because we know the heart is the pumping organ or the engine of the cardiovascular system. It will pump that blood to what we call the pulmonary trunk, into the pulmonary trunk. But before that blood gets into the pulmonary trunk, remember that blood is oxygen poor blood or deoxygenated blood. Before it gets into the pulmonary trunk, it will have to go through some valves. I've told you that the heart is going to have 4 valves. We've already seen 2 of them. Okay, I'll come to them again. We've seen the bicuspid and tricuspid. One of the valves is what we call the right semilunar valve. Okay, right semilunar valve, or that's what we call the pulmonary semilunar valve. Okay, or simply the pulmonary valve or pulmonary valve. Okay, this valve is semilunar because it is having 3 cups which look like half of a moon. Okay, so semilunar. Now this one we are actually viewing the heart from its base. Okay, from its base actually. So we are going to see that, yes, from this actually the left part, the left cups of the semilunar valve. Then of course we are going to have the right cups of the semilunar valve, and then somewhere between them, actually anteriorly, will be the anterior semilunar valve. These are the valves, okay, the cups of what we call the pulmonary semilunar valve. Okay, very important, so that it ensures unidirectional flow of blood from the right ventricle all the way to the pulmonary trunk, Now, another semilunar valve, this time around, yes, you get to know that once the blood leaves, pulmonary trunk, it gets into the, alveolar capillary bed for oxygenation. Then after that, it will leave the lungs, into the heart, okay, by going through, of course, the 4 pulmonary veins and into the left, atrium. Now, in the left atrium, yes, that blood will be pumped, yes, powerfully into the, aorta. Now, for it to get into the aorta, it has to go through this valve, and this valve is actually the left semilunar valve, which is also called the aortic semilunar valve. So this semilunar valve, yes, is going to have, 2 main parts which are very important. It's going to have this left, semilunar cups, which we also call it the left coronary cups. Then we also have what we call the right semilunar cups, which we also call it the right coronary cups. And the reason is that, yes, the left and right coronary arteries, yes, open, at these cups. So once you can see these cups opening, then you should know that we are looking at these kind of, coronary, cups. If it's coming from the left side, yes, it's the left. If it's coming from the right, that's the right, okay, coronary, cups. Then there is another one which the coronary artery, coronary sinus doesn't open into it. Sorry, the coronary artery do not, open, out of it to supply, the cardiomyocytes. And that one is known as the posterior semilunar valve. So we are going to have right and left semilunar valves and then a posterior semilunar valve. But remember that for the pulmonary semilunar valve, we had, right and left and an anterior semilunar valve. For the aortic, we are going to have, yes, right and left and a posterior semilunar valve. Now, because the posterior semilunar valve doesn't bear opening of the coronary, yes, artery, then what will happen is that we also call it the non-coronary semilunar cups. So please understand these ones, understand these dynamics. So that is an important aspect, that, we have to know. Yes, again, we've seen the bicuspid valve, that's the mitral valve, separating, the left atrium from the left ventricle. We've seen the tricuspid valve separating, of course, the right, atrium from the right ventricle, Okay, so these are the valves that you have to know. We've actually done all these ones. Please look at the features that we're going to see, especially in the right atrium, in the right ventricle especially. Then you add some bits to that of the left part as well. Remember that entirely, yes, the bladder is going to flow through, the right ventricle, the right side chambers. That the right atrium, the right ventricle will be deoxygenated blood. The blood that is going to go through the left part will be oxygenated blood. Now, there is one thing that I have to tell you, and that is what we call tetralogy of Fallot. And actually, when we look at the embryology of the heart, we get to actually know that in the tetralogy of Fallot, what happens is that it's a cyanotic, congenital heart defect, actually. Although developmentally it's a single disorder, but it presents with 4 cardinal signs or symptoms. And that's why we call it tetralogy of Fallot, with Fallot spelled as F-E-L-L-O-T. Remember that someone's name is an eponym, and therefore it begins with capital F. Okay, now, that one, what happens is that there's a defect, okay, in what we call the septum. Let me show you. That one, there's a defect, okay, in the septum. Okay, in the interventricular septum, actually, more with the interventricular septum. Then when that happens, what will happen is that there's also what we call, overriding, okay, of the aorta, or aortic overriding, such that instead of the aorta receiving only oxygen-rich blood from, the right ventricle, the aorta also opens into that of the right ventricle. So both oxygen-rich and oxygen-poor blood will get mixed over here. So it means the cells of the body will be supplied with that kind of mixture. So they won't get maximum oxygen, okay, supply. Apart from that, there's going to be what we call stenosis of what we call the the pulmonary valve. Okay, the pulmonary valve that we saw, yes, there's going to be what we call stenosis, narrowing of the pulmonary valve. If there's narrowing, then it means that as the right ventricle contracts, then what will happen is that less blood will get into the lung for oxygenation. If less blood, then it means that less blood will get into the left ventricle, so left atrium, eventually into the left ventricle, and then less oxygen blood will be pumped into the right atrium to be distributed to all parts of the body except the lungs. So it means that the body part will be starving of oxygen. There will be hypoxemia and of course hypoxia to these cells. So that's another sign that we are going to see, pulmonary stenosis, okay, narrowing. Now this pulmonary stenosis is going to be very important in causing what we call right ventricular hypertrophy. Now because there is stenosis over here, then what will happen is that the right ventricle will have to pump blood even more powerfully. Then what will happen is that there will be thickening of the muscles. The muscles over here will be hypertrophying so that they can aid in the function of contraction to push blood into the pulmonary trunk. And that is why another cardinal sign that we are going to see will be right ventricular hypertrophy. Right ventricular hypertrophy. Now get to know that what happens is that if this one persists, okay, now the pressure in the right ventricle then will become greater because it has actually hypertrophied. If it becomes greater, then what will happen is that blood will be shunted, okay, from actually the from the right parts, okay, because the pressure here will be greater, the blood will be shunted over here because there's a defect over here, so more blood will be coming in here, and that one will be supplied to the rest of the body cells except of course the lungs, So these are some important applications that you have to know regarding the heart, tetralogy of Fallot. So in future lessons, yes, we'll be looking at the coronary circulation, and I will also be looking at, of course, the development of the heart so that you can actually understand all these things. So I'm grateful for your time. May God richly bless you, and I hope it's going to help you in your studies.